Good morning to everybody. Today we are here for the second lab of our course in geomatics, and in particular we are going through the MV usage, and we will take into account all the color management that from our side is something that is really important. So we can start as usual as by launching the software. So I'm going to MV 5.3 and launching the 64 bits version. And now I'm launching the software itself in order to continue with the different commands in the software. Okay, we are here. So we are now quite comfortable with this kind of layout. I remind you that we have the general menu here with these menus, different menus. Then we have a bunch of icons that are something that is, there are commands that are more used than others. So we need that in icons in order to be used more frequently than the other. Then we have the layer manager windows, this one where we have all the data displayed, and we can also, as I mentioned the previous lab, we can detach these windows like the toolbox one, where we have other different commands organized in this folder system. And then in the middle, we have the data display windows. That is the most important because we can see and actually use this data. And here below, we have different bars where we have all the information concerning the image, for example, the reference system, but also all the information coming from every single cell of the image. So we can restart after this very short recap of our layout. We can load a new data. And loading this new data, we are going to the general menu file. We are using the option Open As optical sensor, and like the other times, the first lab, we are going to Landsat, and we are opening the GeoTIFF with metadata. So from the main menu, Open As, optical sensors, Landsat, GeoTIFF with metadata. All right, so we are going to the folder where we store the data. In my case, the data are stored, let's say, in a particular position that could be different from yours, but in urban planning, you see, I don't have this data, still this data, I have that here, and I can go to the Northwestern Italy folder, but instead of opening the Landsat 7 and opening the Landsat 8, all right? So I'm exploding this folder, and you see I have also here the MTL text file, that is the metadata text file. And you see it's starting with LC08, that means that is a data that is acquired from the sensor that is mounted on board of the Landsat 8 platform. And in particular, this LC stands for the facts that in some way these data are already corrected, but we will see that later on. Okay, so I selected this file and I'm opening the file. All right, so you see, as usual, we have this representation where the image, and I can explode in the layer manager here the things, and you see, we are just seeing and watching a part of this image, because if I'm going to the overview, you see, it's always the same scene, but is acquired in another moment. And you see, the visualization is placed at this particular scale in the middle of the image. From when it comes, this setup, is coming from here, from File, General Menu, Preferences. Because here in the Preferences, we have all the default option that the software is using when, for example, you are opening for the first time an image. So, for example, you see, I mean, we have some information concerning the application. So, in order to check, for example, the updates, and here, for example, for the data manager, this is the setup that is coming here, that is coming from this kind of display. For example, you see auto display files on open, yes. So I mean, when we are opening the file, there's an auto display, so the file is displayed. And how this file is displayed in true color. So I mean, just mixing the RGB channels, the three bands, the three sub bands of the visible, in order to display the image that we can see from both the satellites. I mean, this is the true color image. And you see, we have other particular setup and so on. So, for example, if we don't want the true color, we can go in this field here, and you see we can change, for example, in CIR. That means that is a false color, where we associate to the red channel the near infrared bands, for example. So you see, we can change the parameters here. We can also change the directories, and that could be quite important in order to point, for example, in the opening of the files in the same position. You see, if you are not changing anyway anything, I mean, the directories that are used by default, they are the setup, the MV setup directories. You can change your data. For example, you see that in the input directory, you see I'm pointing here, for example, because I mean, I open this data from this path here. And then we have also all the other different things, and you can change all these things. All right, so consider the facts that, I mean, when we are opening, and all the general default can be managed by this menu here that I remind to you is in File and Preferences here, all right? Okay, so I mean, you remember, so we can use the mouse. For example, I'm using the wheel of my mouse, and I can change, you see here, the zoom factor, and having all, I mean, most part of the image that's displayed in these windows. You remember that I can do different things using the data manager window. The data manager windows, again, I remind to you that his here is in the main menu. You see here data manager of the shortcut F4. For example, I can recall the windows from here. This is the window. Or I can call the, for example, I'm closing that, or I can call the data manager window from the icon here. You see, data manager. All right, so let's have a look to this kind of data, because are quite different from, I mean, are more or less similar, but there are more bands in comparison with the Landsat 7 data. So this is the Landsat 7, Landsat 8 acquisition. And for example, you remember the meaning of the name of the file. And for example, at the end, we have the American format acquisition date. And so in this case, for example, we can understand that that image was acquired the 14th of April in 2020. So this year, during the lockdown. So the satellite, of course, is not taking care of the lockdown and is acquiring this data. So you remember that for the Landsat 7, we got an image from 2002. So after 18 years, we have another image. And so, for example, these two couples of images can be used in order to compare different data. So you see, in comparison with the Landsat 7, there are some differences, because, for example, you see here there are no more any conventional numbering of the bands, but you see there are some names, some plain names. So, for example, you see that we have a couple of blue bands, because in brackets we have the central wavelength of the band acquisition. And so, for example, you see the first two bands in 0.44 and 0.48 are both in the subspectral band of the visible of the blue. So you see the first one is called coastal aerosol, because it's mainly used in order to check and to find aerosol in the coastal area, and this particularly important, this band, for all the marine, the sea application. Then we have again blue, green, and red band. You see here we have the near infrared and the mid-infrared one and mid-infrared two. So I mean there are no difference from Landsat 7 apart from the facts that in Landsat 8 a blue band, an extra blue band has been added to the sensor. Then we have the band that is called panchromatic. That is, you see, is centered in the point around 60. That I remind you is the band where all the visible and the near infrared is acquired all together. That means that the band, the first data set, I mean the first 7 bands, have a geometric resolution of 30 meters, 30, while this band here has a resolution of 15 meters. Then we have this extra band here that is what has been added in the Landsat 8 that is called Cyrus, that is, you see, pointed and centered in 1.37 microns, and this is a band of the mid-infrared that is used for, let's say, atmospherical applications, because I mean, in this band, you can easily see all the clouds, but in particular, you can also have some information concerning the water content of the clouds. While the fourth data set is the thermal infrared. You see, differently from Landsat 7, the two thermal infrared band, 1 and 2, are acquired in two different central bands, 10.9 and 12 microns. And then we have the last band that is something that is not a real acquired band, because it's mentioning the quality of the data. So it's something that is representing visually the quality of the acquisition. All right. So you remember, then if I'm clicking here on band selection, I can have another synthesis here. For example, if I want to have a false color image, for example, near infrared associated to the red channel, the red bands associated to the green channel, and the green band associated to the blue channel, I can have this kind of representation. If I'm loading this data here, data will be superimposed on the image. Otherwise, if I'm loading in a new view, that means that I will have another view added to the mid windows of the layout. Let's just load that in not loading a new view, but loading simply the data. Let's see what is happening. So we are loading the data, and now I'm closing the data manager. You see I have this representation, and you see that now I have the two syntheses, the two RGB images that are both in the same view. So for example, now in top of the list, I have the false color image. If I'm taking out the visibility of this image, you see underneath, I have the visible one, all right? But both the view are in the same, I'm sorry, both the color images that we have created by associating 3 bands to the different 3 channel of the visualization, so the RGB channels, both these color images are inside this view, all right? And for example, you see in this view, if I'm clicking here, I can also, by clicking with the right button of the mouse, I can rename this view. For example, I can rename that like test, or let's check color test, all right? And clicking OK, you see, now we have a view that is called color test, all right? So maybe I can close the overview here. And for example, I just recall the data manager windows here. And for example, what I'm interested in, for example, is just to see the panchromatic view. All right. So I'm clicking on the panchromatic view, that is the image acquired again in all the visible plus the near infrared, and having all these energy that is going to the sensor. That means, we have explained that in the theoretical part of the course, we can reduce the dimension of the cell on the ground. And so that means that this image has double the resolution. That means that instead of 30 meters, it's 15 meters. So in this case, of course, I can load that only in grayscale, but if I'm telling load data, I mean that will be in grayscale. But I mean, now I want to load that in a new view, and I'm loading that in grayscale. All right. So you see, the our window, our area of the display has divided in two different pieces. All right. And so, for example, now by default, because that is stated in the preferences as we've seen before, this splitting of the screen is vertically. But you remember that if I'm going to views, I can split that into horizontal view, for example, like this one. You remember now these two kind of views are not linked together. So if I'm going, for example, with the hand in order to pan the image, and you see, pay always attention to the facts that we have one window selected time by time. So this is selected the second one. So if I'm going and clicking on the first one, you see now I selected the first one. All right, so you see here we have two different scales of representation, and I'm moving these things separately from one from the other. So if I want uh, to uh, to link the views, or to move the first one or the second one, and accordingly the other windows, I should go to the view command and just pressing link views. Okay, link views, you see we can propose a geo-link, we can link all, and okay, we can just press okay. And now all the two images are linked. So you see when I'm moving with one image, I'm moving also accordingly to the others. So for example, if I'm going again to Genoa, you see here, okay, we have the two representation. This is the first color where we have all in red colors. We are sure for that because we mentioned that in the theoretical lecture where we describe the interaction between the electromagnetic energy coming from the sun and the Earth's surface, and by using the spectral signature. So, for example, here we are sure that whatever is red is vegetation, whatever is very dark is for sure water, all right? And this is the image acquired in the panchromatic. So, altogether visible and the near infrared. And you see, if I'm moving here, you see, and you can detect that the geometric resolution is quite different, because here is better than this one. All right. So this is the Genoa Harbor. All right. Okay. So we can move that. So now we can add some information. For example, what is very interesting is just checking, and you see, using this link, we can use more than 3 bands, because we are more view, and in more view, for example, we can detect how at different geometric resolution the particular spots of the images are represented. But for example, what can be interesting is the fact that, we can also see the same data sets, for example, the 30-meter data set, but using different colors. And for example, you see in here, we have two images loaded, all right? So I'm moving to these windows here. So you see we have this cyan layer here that the framework that states that this is deselected from the graphical point of view, and here that is highlighted means that I mean now we are working on this kind of view. And let's go to do something that could be quite interesting here, because I mean, if we are going to display here to the main menu, once we have in the same view more than one images, more than one image displayed, because I remind so you, if I'm taking out the visualization, you see beneath this false color, that's the true color. You see here. All right, so we have two images. So when you have two images in the same view, no matter if these images are, I don't know, in colors or in gray tones, I mean, is the same things. You can activate using, for example, display these things here, these things that are called portal, blend, flicker, and swipe. All right? Let's check what is the meaning of these things, considering that this portal and view, blend, flicker, and swipe have also the correspondence in the icons. Because here, you see at the end, we have these icons here. You see portal, blend, flicker, and swipe. All right, so when we, and you see, if I'm moving to the other windows, you see that these icons are not more active. That means that these options, as I mentioned to you before, is active, you see, only when we have more than one image of the same view. All right, so let's check what the portal is doing. So if I'm clicking portal, you see, I have a small windows here that is also added here. You see, it's in the windows. This is the, in brackets, we have the P that stands for portal. So you see, if I'm moving the image in these very small windows, I can see what I have in the other view. So I mean, the bigger one of the first view is the first color, and beneath that or over these windows, we have the visible. So you see, for example, that in correspondence to the vegetation here that is really reddish, I mean, the visible is quite, I mean, quite dark, and it's quite difficult to understand that these things here is vegetation, you see. All right. So, for example, if I'm moving with this one, you see, it's very difficult to understand, for example, only checking on the visible on these small windows that this is, I mean, vegetation. It's more clear from here, right? So if I don't want to have any more this portal, I can just click on portal here again, and you see that I have clicking again. I have another portal. If I want to erase this portal, I can do in this thing in this way here. I can click. Now I have two portals. I can click with the right button of the mouse on the portal, and I can remove this window, and I can remove also the other. All right. So you see now I have not any more the portal. So which are the meanings of these three other things? For example, the blend. If I'm clicking on blend, look at what is happening. So you see, it's blending. So is I mean is something that is visualized in which I mean you can see with these effects, with these graphical effects, the two images. While, for example, if I'm using the flicker, this is flickering, you see, okay? But the effects is quite the same. And if I'm using the swipe is this kind of graphical effects, a sort of windows that is moving one over the other. And of course, I can leave these things as it is. And so, for example, if I'm going to the second view, okay, and I'm going to recall the data manager, for example, one thing that I can do is just to check the thermal infrared. Let's check the thermal infrared too. Here, I'm loading that in these windows here. So you see that is active, these windows. I'm loading this data as grayscale. You see, we have the grayscale here, and this is the thermal infrared that more or less is a data that is related to temperature. Just generally speaking, it's not really true, but we will see that in the theoretical part. But you see, I mean, underneath these things here, we have the panchromatic. Here we have the emission that is coming from the ground, while here we have reflection. Okay, I can do the same things here. For example, I can use, for example, the blend in this case. Okay, so you see, I can have more different effects in different windows in order to see at least visually more than 3 bands, because in these windows I'm checking, I'm using 4 different bands, the 3 visible and 1 of the infrared, and here I'm using more than 1 bands because I'm using the panchromatic. In panchromatic way, I'm using the high resolution, high geometrical resolution bands and the thermal emission bands. So you see, I can use these different things from here. All right, so I can close these effects. Otherwise, it's annoying, these things here. So I'm also closing these things, just simply clicking on that. So we have all these things here. And what we can do, for example, we can move again in Genoa, in the Genoa Arbor. And so, for example, just to make you understand that this is the thermal emission, you see by convention, brighter tones, let's say, means higher emission in this case. So whatever is bright, it's the meaning is that is warmer than other things. So as you can understand, the urban part of Genoa, of course, is warmer than the water of the sea, all right? And this part of the city, you see, it's warmer than the part of the hills here. They are not exposed to the direct sunlight because they are in shadow. So this part here is colder than this part here of this hill. All right. So, it's quite understandable, these things. All right. So what we can do in this image, we can go through also the other menus. And so, for example, you see here, you can also change the contrast. For example, if I'm uh, uh, taking out the visibility of these things here. And so you see now we have selected that. I can, for example, just using this bar here, I can change the sharpening of this image. You see, I can change the luminosity here, all right? Or I can change the contrast, for example. You see, this is the maximum contrast of the image. So here, in a very qualitative way, I can change brightness and contrast of the image in order to have a more clear display. For example, here you see I can uh, I can check easily, for example, every single block of the buildings, every single building block. So why before, if I'm going here to whatever. So for example, just clicking reset brightness and reset contrast, you see it could be more difficult to do these things here, just resetting everything here, you see? While if I'm changing, for example, simply the contrast, you see, I can see better some things. All right, so these are particular options that are, you see, are very, and I can go back to the original visualization just with these icons here, that is the reset of the function. And I mean, this is very qualitative, the usage of these particular buttons. While if you are going here to optimize linear, I mean, this is the stretching of the image. I mean, the stretching of the image is a particular option that is explained in, if I'm not wrong, in the fourth lectures of the theoretical part. And I mean, is used in order to improve at the same time both the contrast and the brightness of the image. For example, if I'm going to Gaussian here, and then just simply clicking on Gaussian, you see in the same operation, I'm really improving the visibility of this image. I mean, it appears to be much better than the other, than before. If I'm doing the same things here in the first view, and I'm going, because you see by default, and this is stated again in the preferences, by default, the software is using an optimized linear. While if I'm going, for example, also in the first view with the Gaussian, you see that using the Gaussian, I mean, it's much more clear, the visualization. I mean, our eyes are, for example, for sure, I mean, looking better this image. I mean, this image seems to be better than before, and it's easier for us with our eyes, just simply staring at the image, just to extract in a very qualitative way some information. For example, you see here roads, building blocks, and other pieces of the airborne. You see here, for example, boats or vessels that are going out from the harbor, because you see we have also here these things here that is meaning that is going in that direction, that is exiting for the harbor. So you see, just simply using these things here, we can have some very interesting information. All right, so now what we can do, for example, now we can do another things. So we will check how to use multiple windows, and how we can load different images in the same views. And we also applied some processing in the images using and possibly changing brightness and contrast in a qualitative way with this bar, or using the contrast stretching option and using, for example, these things here. I explained these things in the theoretical part. We will use that more times during the labs. So don't worry, this is not the only time that we are using that. Now we want to use colors. And in order to use colors, I mean, it's better to recall a very important concept that I introduced in the theoretical part, talking about colorimetry. So, I mean, the definition of the quantitative part of the color management. In order to do that, for example, here we can use this particular figure. Okay, in this particular figure, we are we are fully understand the concept of principal and complementary colors. And you see, if we are in a RGB system here, RGB, if we are projecting these three fluxes over, for example, a white screen, and in the part where this flux that is coming from a projector that is projecting this particular color, this principal color, is not intersecting any other color, we have the principals. So here we have the red, here we have the green, and here we have the blue. So the RGB system. When these fluxes are intersecting another fluxes, here we have the complementary color. So for example, here we have yellow, here we have cyan, and here we have magenta. While these three fluxes are overlapping all three, we have the synthesis, the sum of these three things here, that could be white if they are saturated, these stiff axes, or could be a particular gray tones. So that means that being white and black, the extreme part of the grayscale, I mean here we can have whatever gray tones we can imagine. So from these things here, just to recall, I mean, if we are taking two parts, two equal parts of green and blue, and we are not using the red, the sum of these equal part of green and blue give the complementary color of cyan. So cyan could also be intended, this is according to me, the best way to learn the complementary colors. Cyan, you see here from these figures, is generated by the absence of red. All right. So, I mean, you can consider the cyan as the complementary color of red, in which in the cyan there are not red components. All right. And I will also explain that in this way, because now we are using an additive system, an additive synthesis. If we are using the subtractive synthesis, so if we are subtracting from the white, that is characterized by the facts of having three full principal sum, and if you are subtracting by the white, that is R plus G plus B, you are subtracting the cyan, that is G plus B, the results will be R, red. So this is why the cyan could be considered the complementary color of red, because, for example, if you are subtracting from the white the cyan, the results will be the red. If you are subtracting by the white RGB, you are subtracting the red, the minus red, the results will be green plus blue, so the cyan. You see, you are passing from red to cyan, passing through the white, all right? So the complementary color of blue is the yellow, that is the sum of R and G. If you are subtracting R and G from white, RGB, the results will be, of course, blue. If you are subtracting from the white, RGB, the blue, the results will be G and B, R and G. So that means yellow. The complementary color of green is the magenta, that is the sum of R and B. So if you are subtracting from white, RGB, R and B, the results will be green. So you are subtracting from the white, you are subtracting the magenta, you will have the green. If you are subtracting from the white, RGB minus green, the results will be R plus B, so the magenta. Okay, so now we have more clear the meaning of the principal color, blue, green, and red, and complementary color, yellow, magenta, and cyan. All right, so I can close these windows here, and I'm going back to our software. So in our software, for example, I mean, I can just take out from the visualization, from the display, the second view here. So I'm clicking with the right button of the mouse, and I can remove this view. All right. That doesn't mean that uh, uh, I'm erasing the data, or I'm taking that out from the data manager, because you see, if I'm taking into consideration the data manager, all the data are still there. So I mean, just taking out the views doesn't mean to erase or to take out data from the data manager. All right. So we have our view here, all right? So for example, now we can move to another position. So I can just zoom out, and I want to go, for example, in Torino, that is here. You see, this is Torino, and you see, this is Torino. This is very dark in a fourth color, the Po River, and this is the vegetation that is more or less red. For example, if we are going here in Torino, in this part here, you see that it's very reddish. This part here, this is, I mean, for whom is living in Torino, this is a very interesting place. For example, you remember that I can go to the reference map links in order to check what is these things here. And when I'm taking these things here, you see that is the Parco Naturale di Stupinigi. So we are here. Stupinigi is a very important castle that is in the southern part of Torino. So, for example, if I'm centering these things here, you see we have here, we have the castle, and here we have all this vegetation. So let's recap. Why the vegetation here is in green, is in red? Because we have associated to the red channel of the visualization in the RGB, the band in which the vegetation reflecting most, all right? So here the vegetation is red because we have associated the near infrared band to the red channel, while we have associated to the green and blue channel of the visualization two bands, red and green. Red, where we have a peak of absorption of the vegetation. Green, we have a maximum reflectivity in the visible, but anyway, considering the spectral signature of the vegetation, I mean, the reflection in the green band is much lower than the near infrared one. So the results here, of course, is that the vegetation is, of course, red. All right? So this is our first possibility. So, for example, if I want to have the vegetation in pure green, how can I represent this image? For example, if I'm taking out the visibility of these things here, you see, I have the visible. It's not very good. I mean, it's a Gaussian. I'm taking these things here. I can take the Gaussian here, and you see I have these things here that is in green. And I, for example, if I'm taking the flicker, you see I have to give visibility to these things here. You see, I mean, I have here the vegetation in green and in red. All right. So I mean, why I'm doing these things here? Because I want to make you understand the real meaning of the colors. Starting with this first consideration. You see here, I can use the different spectral bands in order to color different surfaces in different colors. So the results of this operation that we are doing here is the fact that, of course, the color is not an intrinsic characteristic of the surface itself, but it's just the way, in our case, on how we are associating spectral bands to the channel, to the color channel of the visualization of the three principal colors, red, green, and blue. So I'm not really satisfied, you see here, about the green color of the vegetation. You see here I'm using a swipe, and I'm closing this swipe here. I'm not very satisfied on that, and I want to have this vegetation greener than that. How can I do that? Okay, let's open the data manager here. Okay, these are our data. I'm opening the band selection in order to control better the association. The question is, stating that I want to have all the vegetation very green, how can I can mix this band in order to have the vegetation green? So if I wanted to have the vegetation green, you see I'm moving to the green channel here. And what can I do here? Uh, Taking into consideration the spectral signature of the vegetation, I'm associating to the green band the near infrared band. Okay, and what can I associate to the other bands? For example, to the blue band I can associate the green original band, and to the red one, for example, the red band. All right, so I'm associating to the RGB red, near infrared, and green, okay, in this way. And I'm loading that in a new view, okay? And I'm loading this data in a new view. Okay, so we have here the new view. Now I can just move on that. I'm sorry because I need to set it. Okay, here. You remember, of course, it's not linked. So I'm going to views. I'm linking the two displays. I'm linking all. And now also the second is linked to the other. And so you see that in a uh, uh, simple way, I can represent the vegetation in red and also in green. So we have the two principal colors. If I want to do the to represent the vegetation in the other principal color, that means in blue, how can I do that? I can do that, on the same principle. So I'm opening the data manager. I'm selecting the band selection. And what I should do, I'm going to the blue channel and I'm associating to the blue channel the near infrared. And I will associate to the red channel, for example, the red, and to the green channel, the green. And I can load that in a new view. Okay, I'm loading that in a new view. So you see that is all is bluish. This is, let's do again in the park here of the castle. Here it is. You see, this is not linked. So what I should do, I need to go to views to link the views. You see, we have already a link. I can just take into consideration the possibility to link all here and then just press OK. And you see, I have the three views, all right, where the vegetation is in one of the three principal colors, red, green, and blue. I can do also another thing. So, for example, if I'm going to the data manager and checking band selection, I want just to have this vegetation here more or less white, or trying to, not really white, but to have this vegetation in brighter tones of a gray scale. All right? How can I do that? I can associate to the three different channels of the visualization the same band, the bands in which the vegetation is reflecting most. So I mean the near infrared. So I'm associating the near infrared to the red, again the near infrared in the green, and again by double clicking the near infrared in the blue. So the same band. I'm loading that in the new view. If I'm associating in an RGB the same bands, the results will be, of course, a gray tones visualization. I'm loading that in a new view. Now I have four different views here. I'm closing here. I'm moving these things in the middle. Now I'm missing these links here. I'm going to views to link all the views, link all, and then clicking OK. And you see that now I have the three principal colors, and here the vegetation is more or less whitish, or better, is a gray tones that is brighter than the others, than what is not vegetation. So you see that I can color our different surfaces in the color I want. So I mean, again, The color of a particular surface is not an intrinsic characteristic of the surface itself, but it's only the way in which this surface is reflecting energy, or the way in which, for the display, from the display point of view, I'm associating the different bands to the different channel of visualization. All right. So now we need to uh, to work with complementary colors. And working with complementary colors, let's use these things here. So we are going to this view here. You see the first one. Now you see we have 4 views. And now, for example, we can change the name of these views. This view was, and it's also better to take out these things here, the other visualization in the true color. So I'm going to click with the right button of the mouse, and I'm removing these things here. So in every single views, you see here, I have one only image, all right? So for example, I can change this color, and I rename this item, calling that red plus, for example, here, the complementary color of red. And you remember that the complementary color of red is cyan. Okay, so I'm calling these windows red and cyan, because on this window I will now create an association in which all the vegetation will be represented in cyan. How can I do that? Of course, again, data manager. I'm on this first view. I'm checking the band selection. You remember that I told you that you can consider the cyan as the complementary color of red, taking into consideration that the complementary color of a primary color is the absence of the primary. So that means the cyan is the sum of the other 2 principal colors, not the red, so green and blue. So what can I do? I can associate to the green channel the bands in which the vegetation is reflecting most, so the near infrared. I can associate to the blue band again the near infrared by double clicking, and I can associate to the red band, to the red channel, I'm sorry, the bands of the acquisition in which the vegetation is reflecting less. That in this case, it's the red band. So I mean the association in RGB could be red, near infrared, and again near infrared. All right. I load not in a new view, but in the same view. Okay, I'm loading this data. Look at what is happening, and you see this is the the complementary color of red, that is the cyan here. All right. So I'm going to the second view right now. So the second view is this one where I have the green. I'm changing the name of this view, and I'm calling that green plus complementary color of green, that you remember is magenta. But this kind of violet. All right. So the magenta is the complementary of green. So I should associate to red and blue channel the near infrared band. I'm sorry, I did a mistake. I'm going to the green one and associate in this case the bands in which the vegetation is reflecting less, so the red band. So the association in RGB will be near infrared, red, near infrared. I'm loading that in the same view, in the same second view. You see here, and now I have here the magenta. All right. Now I'm going to the third view where I have the blue. I'm changing the name here, and I'm taking blue plus yellow. Okay, that is the complementary. So that means that I have to associate to red and green channel the near infrared.
and I have to associate to the blue channel the red band. I'm loading this data, and you see I have that in yellow. All right. So the last windows, I can change the name, and I can call that white plus black. This is not really white, and that will not be really black. How can I do these things here? You remember here I have the near infrared to all the three channels. In this case, I can associate with the band selection to the three different channels, again, the bands, the spectral bands in which the vegetation is reflecting less. So the red band. So I'm associating red band to the red channel, red band to the green channel, red band to the blue channel, and I'm loading that. And you see that the results is something that is related to the negative of this image. Whatever was white here, that was vegetation, now is very dark, is very similar to black. So now we can go to the first one, and we can use the four different options we have in order to animate the image. For example, to the first windows, we can use the blend option. You see here, so we are passing to red to his complementary color cyan. In the second one, we can use the flickering. Here it is, okay? And in the third one, we can use, for example, the swipe. Okay, so you see there everything is moving. In the last one, we can use the portal. You see, I have the portal, and you see that looking at the portal, I mean, the vegetation that was really bright now is very dark. Whatever was dark and now is bright. You see? So this is a very, according to me, good example, also using this kind of animation in which you can fully understand the meaning of the color managing. Having done all these things here, maybe it's quite funny just to have all these things flickering, moving, swiping, and so on. Maybe could be interesting just to save these things here, so I can record the commands in order to save this arrangement of the layout of MB. So we can go to File, to the main menu, and in View and Layers, save this layer. I'm saving that usually here. The extension should be JSON, you see here. So I can call, for example, that color management dot JSON in order to have these things here. And maybe if I need that again, I will have already available without reconstruct all the different windows. All right, so I mean we are well done. I mean I'm very satisfied of this color management, but we should add something more. In order to add something more, I mean I only need one single view. So I'm starting with the last one, and I'm closing and I'm removing this view in order to have at the end only one single view. So I am removing also the third one and the second one in order to have only one single view. All right, and this one single view, I don't want to have this effect, this blending effect, so I'm closing this blending effect. And I'm also just mentioning the fact that, for example, I don't want this kind of image, the cyan, the vegetation colored in cyan. So I'm removing this image, but I'm also removing this one. All right. So I'm in the initial option. I have this layer manager that is this layer that is called red and cyan. I'm right clicking here in Redis Cyan, I rename the item because now I want to explain you how to use this option. That is the density slicing option. So now we'll use the density slice. All right, I explained the density slice in, if I'm not wrong, in the fourth theoretical lecture. And now we are implementing this density slice option. In order to implement the density slice option, I just remind you that the density slice is a sort of operation that is working in using only one single spectral band. So that means that going to the data manager from here, for example, I can just choose the near infrared and load that and visualize that, display that in grayscale. All right, here. So this is the band of the near infrared where you can check here. I'm moving in this image. Then whatever is bright, and maybe I can go here and use, for example, the Gaussian here. You see, whatever is very bright, all these pieces here, all this part here, are for sure vegetation. Whatever is very dark, for example, here, is for sure water. And also here, for example, you see, you remember in Torino, you see here there are the lakes, the quarries that we have southern part of Torino. And you see here, this is the Po River. And you see I can also just follow the flow of the Po River here, you see, okay? And just to follow the river here, you see, this is the Po River that is getting larger and larger, downstreaming, all right? Okay, so this is the image, and of course here whatever is very bright is more vegetated of other things, where whatever is dark is not vegetation at all right? So let's go, for example, here, that is a very good example, this area here, where we have the Po River that is very dark, is very large, and there are very bright spot rectangles that are for sure. There is vegetation. These are agricultural fields for sure. You see? You see, for example, here that you have also a paleo meander. So an older flow of the Po River that is moved in that direction. You see? It's very clear here, but also here you see you have some signs of these things here. This is a flooded area. I mean, that is subjected and is vulnerable to floods, of course, because we have signs of that. All right, so if we are going here, we are exploding, I'm sorry, we are exploding this thing here. You see, we have only the near infrared. So in this case here, when if we are right clicking with the mouse in this particular image, apart from the fact that, of course, also I can also rename here the file. That means that I'm not renaming the name of the file, but I am renaming, I'm just giving an alias to this file in the layer manager. So it doesn't mean that you are changing the name of the file, but you are only changing the naming when visualized in the layer manager. Here you see we can use this new raster color slice option. Okay, that is another way to manage colors. So if I'm clicking here, you see I have these windows that is the selection of the bands. I mentioned to you, and also from the theoretical part, we know that the density of the color slicing is working only with one single band. Here we can choose the band. Let's choose the near infrared, what we have visualized here, and click OK. So you see here has been created this colored image. How is working this color image? I mean, this is the classical and very didactical windows of the density slicing. Why the density slicing name? Because let's concentrate on this diagram here. This diagram, as you know, and we from the theoretical part, but this is the first time that we see that in the lab. This is what is technically called the histogram. What is the histogram? The histogram is a diagram you see here where on the x-axis we have the digital number of the cell that in this case, in the case of Landsat 8 that is calibrated, you see the digital number are changing from 0 to more than 50,000, in particular 56,000 and more. Why that? Because the digital number is stored in more than 1 byte, differently from Landsat 7, because in Landsat 7, the data that you have available is not calibrated, but we see that the next lab, the ranging of these values of the Landsat 7 are ranging from 0 to 255. So 256 different values. There are the maximum combination of values that you can generate using only 1 byte of sampling. So using 8 bits of sampling. Here, they are using more than 1 byte. They are using at least 2 bytes. And in 2 bytes, you can split all the values in more than 50,000 different values. So in the x-axis, you have all the digital number. What you have in the y-axis? In the y-axis, you have the frequency. What is the frequency? Is the number of cell of this band, of this image that we have displayed, that have this particular digital number. So if I'm going here and I'm clicking here, you see, I can, this is not the right option, but I can understand, for example, here, how many cells have this particular digital number. For example, here is the more or less 14,000. In 14,000, you see we have less than 20,000 values, 20,000 cells that have this particular digital number. All right. So the density slicing is the possibility to slice vertically with this colored slice the histogram or the density histogram, because the histogram, what is the jargon technicality of the name, but is called in plain density histogram. So the density slicing is the possibility to slice, to cut this density histogram in pieces. And how you can cut in pieces? You can cut in pieces by defining the range of values and associating this range of digital number values a particular color. And these are the different slides, and these are the different colors. So that means that in this image, whatever is bluish have a quite low values. Whatever is turning to green, yellow, and then red means that have very high values. All right? This is the graphical representation, and this is the table. In the table, you see very simply, you have the first color and the range of values that are associated to the first color. All right? So, I mean, this is a way, and we can just move these things here. This is a way, for example, if I'm choosing these things here, just to represent one single band in colors. So this is another way to use color to manage our data. So I mean, that could be quite interesting because you see, I can represent in colors also one single band that you can represent only in gray tones. So this is a way to represent an image in colors. But apart from what is visual, can be visually seen. So an image that being in colors maybe is more contrasted for from our eyes point of view in comparison with the same image in gray tones. For example, this one, you see, maybe here I can get more details. But what is very interesting here is that considering, as I mentioned since the beginning, that our main task is trying to extract information from data, in this density slicing option, we can, for the first time, we can try to do these things here. And now I will show you how we can do that. All right. So, for example, we know that in this image, uh, if we want to extract all the water, we know that in band 4, the water has a very low reflectivity. So I mean, not in the band 4, I'm sorry, in the near infrared, the water has a very low reflectivity. So that means that, if we have low reflectivity and we can represent this low reflectivity in blue, that means that whatever will be blue in this image using the density slice could be water. Let's try to do these things here. So, for example, let's try to change these different intervals. You see, we have 16 different intervals of data. And I mean, they are too much because I want just to have one single interval. I just want to have one single interval in which, our water, all the water, will be represented in blue. All right. So how can I do these things here? I can, for example, just clear this color slice. Okay. So now I don't have any particular color associated or slices associated to the image, to this band. So, for example, if I want to understand which is the color, the reflectance of the water, I can just do a particular things. And so just to check here that is dark, and so I can, for example, add a color slice. You see, if I'm adding a color slice, of course, all the image will be colored. Is only one single of these slice, so the image will be colored in blue. My question is, can we color in blue all the water? So first problem, we need to change the color. So in order to change the color, I can go with the mouse here. I can click with the right button of the mouse and I can select the blue. All right. So first things done. Second things, you see, this is the minimum value and this is the maximum value. All right. I have the impression that the blue is, I had to change the maximum value because the water is a very poor reflectors in the near infrared. So for example, if I have a range that is ranging from 5,000 to 55,000, maybe I can change the maximum and just to try to put that in 10,000, for example. All right. So you see, I select these things here. And you see, as soon as I define these things here, I'm sorry, right, as soon as I do that, you see that magically in this image, the water has been colored in blue. Of course, there are also other things that are not colored in blue, but you see here that if I'm going for example, just close to Torino, just following upstream the city, I'm going here to Torino, and you see that here you have for sure all the water in blue, but we have also other things that are not water at all. I mean, these pieces here are pieces of buildings. While if I'm going downstream, you see all the quarries here for the sand, where they are extracting sand, that is south of Torino, are colored. These are lakes. And for whom is from this region, for example, here is part of Torino. These are the two lakes that are close to this small city that is called Avigliana. These are these two lakes. For sure are blue. Let's check what is happening in Liguria here, just on the coast of the water. You see that the water is perfectly blue. You see here also in Genoa, all the water is blue, but pay attention because there are also other pieces that are not blue. All right, so that means that I added some noise. Maybe the maximum value is too big. So for example, I can modify that in 8,000, for example, just press enter. And you see that in these things here, I really reduced the rumor here, the noise. You see, maybe it's too much. I can go to 6,000. Let's check. And this 6,000 is much better. You see that also here in front of Genoa, there are these very small pieces here of cells that are, of course, ships, right? So you see here in a very simple way, let's check if we extracted all the river. You see the river using these very small things here, I cannot take all the river, so that means that it's too small. Maybe if I'm going to 7,000, okay, you see now the river is okay. And here I don't have any more noise. Let's check. I have, of course, these pieces here that are the shadows or the clouds, because this is not water at all. If I'm going to the water here, you see it's not bad. All right, whatever has been selected as water, and also the vessels, the ships are taken out from the extraction. So you see here, you can simply understand that simply using this density slice option, so working with colors, if doing this example, we can extract the water from one single band, that means that if I can color all the water in blue, that means that, I mean, it's very easy to understand also at this point of the labs that if from the band or the near infrared band, I'm taking out from the image, like I'm doing that here visually, I'm using a mathematical operator that is taking this interval of data and they are storing that in a new image. That means that it's very easy not only to visualize the water on the image, but also to extract this information. And of course, I mean, just doing these things here, you can fully understand that, I mean, is our final aim, so that is extracting added value information from the data, is very clear also from here. Because you see, I mean, if I want, for example, to extract or to calculate the surface of water, or to see in multi-temporal images, in images acquired in different times, if the water has changed, I mean, that is a things that I can do. So, I mean, I can check if there's any difference in water. And maybe we can do these things here. We can do these things here just working with different data. So, for example, now I'm closing these things here, okay? And you see, when I'm closing these things here, I didn't save it. So, I mean, the results is as before. So, I can just, I'm sorry, it is, I'm going, and I close these things here, okay? I mean, if I'm opening another image, or if we are using another image, for example, last at 8 or 7, acquired in another time, we can just perform this possibility, for example, to check if the water has changed during time, for example, the surface of water. And this is the things that we will do later on in another labs. So you see, using the density slicing, we are the density sliced added to the overview. So if I'm closing and I'm removing this layer, of course, I'm removing these things here. You see that, I mean, this is the density slice is something that has been applied only in the displaying phase. So I mean, I not save anything. And so I can also recall these things whenever I want. All right, if we are going here again, now we can use another example. So if the first example was using the near infrared and stating that in the near infrared the water is a very good absorber of energy, now we can use the opposite examples. You see here we have very bright pieces of crops. I want to color in green these pieces of crops. So how can we do that? Again, right clicking in the layer manager here, uh, starting this new raster color slice option. All right, we are using again the near infrared. Okay, we are in the same position as before. You see that these things here are in green, so they have these values that seems to range from, let's say, 25,000 to 40,000, something like that, right? Because they are green. So as before, we can clear all the color slices. We can add one slice, right clicking on the color. I'm sorry, left clicking with the mouse on the color. We can put that in green. All right. We can select, as we mentioned, 25,000, just a guess, just an hint, and the maximum could be, for example, 40,000, like we mentioned. All right. And you see that seems all the vegetation seems to be extracted, in particular crops. You see that here, if I'm going in this way here, you see that whatever is very bright, not everything, because maybe 40,000 is too less. Let's check 45,000. You see I'm adding points. Let's check 50,000. Okay, you see that now we have extracted whatever our crops, so agricultural fields, were extracted. For example, you see, just going in the southern part of Torino, you see that most of these crops are extracted. Maybe it's better to put at maximum, 56,000. Okay, you see that all these lines here from the graphical display, you see, has been colored in green. And this color in green, you see, is highlighting all the agricultural fields, or most part of the agricultural fields. And here we have something that is extracted, that is of course not agricultural fields. We are in the middle of the mountains. What are these things here? You know very well, this is snow. This is an acquisition, I remind to you, that was done in April this year, and in 14th of April 2020, here in the southern part of the Piedmont region, there were full of snow, still snow. So I mean, this is snow that in the near infrared is reflecting is a very good reflector of the snow, has the vegetation. So you see that in this case also the snow was highlighted. And you see here that in the coastal part of Liguria region, you see that is nothing. Nothing is colored in green. So that means that there are not agricultural fields, but of course, I mean, the orography of this area is very complicated. So I mean, it's very difficult to cultivate anything. While here we have also some outliers, some noise, because for example, also the clouds are a very good reflector, not only in the visible but also in the near infrared, and appears to be white, to be green. I'm sorry, in this case. All right. So just taking into consideration these clouds, let's check another thing. I'm closing these things here. All right. And now, using the data manager, I want to load in the same view of the density slicing, for example, the thermal infrared, the band of the thermal infrared too. I'm not loading that in a new view, and I'm loading as a grayscale. Okay, so you see here we have also these things here, the thermal infrared. You see, thermal infrared. These are I mean clouds. Why in the thermal infrared the clouds are black? Because I mean by convention, and having mentioned to you that I mean darker darker gray tones means as in the reflection, but extended to the emission means lower emission, while brighter tones means higher emission. That means converting that in a concept of temperature, that darker area are colder than brighter areas. So of course here, all the part of the mountains that is covered by snow, of course, is colder, so it's darker. Here you see that the cultivated field crops, but also the city of Torino, you see here, we are here, is of course warmer than the water and the vegetation. And when we are going to the clouds, of course, considering that the gradient of the temperature is, I mean, the temperature is lowering with the altitude. I mean, of course, the clouds are colder than the Earth's surface, right? So, for example, here, if I want to extract with a density slicing the clouds, what I can do? I can do right-clicking on this image. I can use the raster color slice. I'm using the thermal, okay? And you see in the thermal, the clouds are very bluish. So I mean, they are starting with a very low value. So if I want, for example, to color in white the clouds, I can get out all the different slices. I can add one single slice. I put this color right clicking in white here. Okay, and having the clouds a very low value, I, I, I starting from the minimum that is calculated by the software, by the procedure that is 15,000, and I'm, for example, extending the maximum to 20,000. And I'm clicking enter just to check the results. And you see that the results is very good. So you see here, whatever is white here, it's really something that is connected to very high temperature things. Clouds, for example. Let's check what we have more. You see here there's nothing, and you see here also we have the snow. You see? And nothing more. All right. So you see, it's quite amazing. There's just using one single bands and using this range of digital number of values, we can visualize, and then of course we can extract this data. We can extract things, we can extract surfaces, features, and that means, and that confirm that, I mean, the possibility to extract add information from this data, added value information from this data is really possible, and you can see we can do that with very simple ways, just using the density slicing. All right. So for today, I think that is enough. This is the end of the second labs. And thank you for your attention. And we will meet again for the third labs. Thanks a lot and bye bye.